Hey everyone, and welcome back to another Math with Mr. Oldenborg thing. Today we're going to be dividing unit fractions by a whole number. I don't know why I read the title since they just say it right there. But yeah, let's get with it. So in class today we talked about this pan of lasagna, and one of the things that I told you was the most important part of doing these questions correctly is reading. If you don't understand what it's asking for and what parts, there's no way you're going to get it right. And that still goes back to when I talked about setting up your problem right. You need to, I got to make my marker smaller. You need to make sure that whenever we're setting up division problems, that we're always talking about what we have. I just fixed that so that wouldn't happen. You gotta be kidding me. Oh, these programs. My apologies. Not re-recording. There we go. All right, we talked about what we have much better, divided by how it's shared or how it's cut. And just like I told you in my class, I got my audio track today. Fiskars, the only way to go for scissors. All right, so we're going to talk about how we cut it up. If we don't set the problem up correctly, there's no way we're going to get these right. So, yesterday, Club made a pan of lasagna. My whole is a pan. That's what kids forget. You guys are always thinking, hey, my whole is what I have, and what I have is right here. It's this half lasagna. It's going to turn out it's not. They left half of the lasagna for 4 members of the photography club. So, if I'm thinking about what I have half a tray of lasagna. 4 members are sharing it. Since they're sharing it, I'm dividing by 4. All right? So, half a tray divided by 4. The big thing is, I need to make sure I read the rest of my question. What fraction of the pan of lasagna did each photography member get? This is what matters. This is where a lot of people messed up today. Of the pan of lasagna. They were not talking about of the half. They weren't talking about this. They were talking about the whole. All right? Because what I need to do is cut that piece for each person. And if you notice, each person gets 1, 2, 3, 4 pieces out of that half, right? But they want to know the whole pan. So a lot of you wrote right away, oh, it's a quarter, because I got a quarter. Well, yeah, if I was taking it out of the half a pan, if I'm only looking at this is the whole, sure, they got 1 out of 4 pieces. But they said the whole pan, the original pan. That word, original pan or pan of lasagna, that's what matters, because now if I look, I have 8 slices, don't I? So if I do the math, my 1/2 divided by 4 is really 1/2. I take the inverse operation of division, make it multiplication, and I take the reciprocal of my fraction, so instead of 4 over 1, it's going to be 1/4. And if I multiply that across, each person got 1/8 of the lasagna from the original pan. If I was thinking about this, 4 over 1, that's saying, hey, I have 4 pieces out of what's ever left. Okay? That's where that 4 over 1 comes from, because I'm doing 4 people, so I need 4 pieces. The other thing I want to just touch on really quick is the term unit fraction. We've been talking about this a lot. A unit fraction is different than a regular fraction because a unit fraction tells you what's in 1. So, something is in 1/2. There's 1 piece, okay? 1/4 is a unit fraction because it's just 1 piece. Something that is not a unit fraction, 2/3. It's not a unit fraction because you're saying that you have 2 of something, not 1 of something. A unit is 1 unit, so it gives you a measure. And that's a term you're going to need to know. I love this example. I loved when we talked about this in class. A lot of times you guys will read these questions and be like, well, I don't know the answer. And the big deal is, if you don't know, solve one for it. Well, what numbers do I use, Mr. Oldenburg? You make them up. And when in doubt, I always use easy numbers like 2 or a half because it's going to tell you the same story. So this question said they want to know when you divide a unit fraction by a non-zero whole number greater than 1. So pick a whole number greater than 1. Will the quotient be greater or less than the unit fraction? So what's that saying here? It's saying you're going to solve a problem and then compare it to the unit fraction, not to the other whole number. So if I set this up, they want me to divide a unit fraction. I'll pick 1/2 because it's the easiest. Okay? And I'm dividing it by a whole number that's greater than 1. I'll use 2. Okay? So, if I solve this, inverse operations, multiplication, reciprocal fraction, whoops, I screwed up. Got ahead of myself writing. Where's the eraser? So 2 over 1 becomes 1/2. I am going to get a number less than my original fraction. Here was my original unit fraction. I need to compare my quotient to it, right? So 1/4 we know is less than 1/2. So whenever I'm dividing a unit fraction by a whole number, I'm oh, hi Brooke, hi Bianca, how are you?
Hi.
You're on the video now.
Yay.
Whenever you divide a unit fraction by a whole number, your value is going to be less than the original unit fraction. Give you a second to look at that. All right, your second's over. So we had this model today, and this was showing us picture forms of how to solve these problems. So what I have is up here, I have a whole rectangle cut into 4 pieces. I have quarters. All right, 1, 2, 3, 4 out of a whole. And what we're going to do is we're going to apply these problems to using this model. And I'll probably draw a couple elsewhere so that way we can see it and it doesn't go away. So first, let's do the quarter divided by a half. By 2, even though it is half. I was technically right. So I have a quarter, and I'm going to be multiplying it by a half, and I should get an eighth. So what's it saying? If I'm going to draw this model, this is saying you have 1/4, and you're dividing it into 2. So here, oh, I want my select tool again. Here is where I have a quarter. Well, because 1, 2, 3, 4, this is one of those fourths. I'm just going to cut it in half. And then you might say, well, how'd you get 1/8? You have 2 pieces. Shouldn't you get 2? No, not really. Because I can't think of it as just that 1/4. You have to put it in relation to the whole. Now that I have the whole, I can say I have 1, 2, 3, 4, 5, 6, 7, 8 in a whole, and I only took 1 of them. So out of the quarter, I took 1 out of the 2. But that quarter is part of a whole. And you always want to look at things in relation to how they represent themselves in comparison to the whole. Let's check out a quarter. A quarter divided by 4. So what am I doing? I have a quarter, and I'm going to cut it up by 4. Of course, I'm also not going to divide. So 4 over 1 becomes 1/4. 1 times 1 is 1. 4 times 4 is 16. Again, the math is not difficult. It's the understanding the concept. So let me draw my 4 quarters. Here's my 4 quarters. And I need to divide one of the quarters up by 4. So if I were to count this, I'd see that in 1/4 I have 1, 2, 3, 4. But in relation to the whole, I would have 4 here. Whoa, that's the top of the screen. 4 here, 4 here, 4 here, 4 here. 4, 8, 12, 16. That's where I'm getting my 16th from. In the hole there are 4 pieces. But when I only pay attention to this quarter, there's 1 out of the 16 in all. 1/2 divided by 2. We just did this on the last page, so I'm going to do it fast. I have half. I take the reciprocal, and I should get a quarter. So if I look, here's my whole. Here's my half that I have on the left. I need to cut it in half. But then I also need to cut this one in half. What do I see? I see that in that half, I have 1 out of 2. So 1. Whoops, it's not the pen, Mr. O. Out of how many in all? 1, 2, 3, 4. Finally, let's do 1/2 divided by 4. I should get 1/2 times 1/4 to get an 1/8. Here's my whole. I cut it in half. What am I doing to it? I'm taking the left half. I'm cutting that into 4 pieces, which then I would cut this into 4 pieces. Oh, I like these colors. It's a little side note for you. I have 1 of these out of how many? 2, 3, 4, 5, 6, 7, 8. 1/8. Last thing I'm going to show you is how it's related to models if they give us the problem and they want us to cut it up, or on a number line. So in number 7 over here, this says 1/2 divided by 5. So when I look over here, I have, and I am working on saying less. I'm really sorry. I have a degree in speech communications, and I say on video way more than I do in real life. It's very weird. Here's my whole. I cut it in half. 1/2, 2 halves. It says take both, basically. Cut them in half. Cut them in 5 pieces. I love these unedited versions. 1, 2, 3, 4, 5. Remember, that last one counts for 2. So, what am I looking at here? I'm looking at that I had my 2 halves, which made a whole. I cut each into 5 pieces. I'm only concerned with up here. What do I have? Well, I have 1. Come on, marker. 1 out of, let's count them up. 2, 4, 6, 8, 10. If I were to do the math, let's call it the computation, because we totally did math there. Just because we didn't work with numbers doesn't mean we didn't do math. Math is 80% thinking, 20% computation. Just remember that. We still get the 1/10, because all I'm concerned with, first of all, is this half, the shaded area, and find the unit. What is one of those 5 pieces? A lot of you also realized in class, if you just take the whole number and multiply it by the denominator, you're going to get the answer. Just remember, you need to show your work to prove to the person who's looking at it that you know what you're talking about. And on the number line down here, we have 1/5 divided by 2. So, remember, we like to show the work because it shows we know what we're talking about. But you can see how the 2 are related, too. Here we had a 1/2 divided by 5 because we're cutting it into 5 pieces. Here we have a 1/5 that we're cutting into 2 pieces. 5 times 2 is 10 no matter how you look at it, but the picture's a little different. Because in the top picture, you're going to see that we had 2 halves that we cut into 5 pieces. Here we already have 5 pieces, but we need to cut it into 2. And you'll see that it's 1/10 because when I add the halves into each of those 5ths, and then I go back and count them, I have, oh, that's supposed to be a pointer. Love mistakes, they're the best. Remember, you learn from your mistakes, kids. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So just remember that when you're looking at what you have to start, it really does matter. Sometimes you might get the same answer in this case, but a lot of times if you set the problem up, you're going to get the wrong. Let me show you what I'm talking about. It's way easier. Whoops. Let's go back here 1 second. A lot of people, like we said, had gotten a quarter, but a lot of people also got 8. Let's talk about why for 1 minute, and then we'll wrap it up. Sorry, I had a really good idea, and this is something that needs to be said. Let's talk about why people got it wrong this morning. About half the class did, too. So, I always say, it matters how you set it up. And we said we had half of the lasagna, we divided it into 4 pieces. A lot of kids did this. Now what happens here? There's a big difference between 8 and 1/8, isn't there? When I really look at it, first of all, there's only 8 pieces in the pan, right? Of course. How am I supposed to feed 4 people when each person's supposed to get 8 slices? I would need 4 pans, because it says you have 4 pans of lasagna that you're dividing in half. Well, that would make sense. Then I'd get 8 pieces, because if I had 4 pans and cut them in half, I'm going to get 8. But that's not what we're saying here. Here we were saying we had half a tray, dividing it into 4 pieces. Semantics, words, and really comprehending the question are what matter here, guys. I hope you enjoyed it. No music again today. Instead, you get the cutting sound effect. Fisker Scissors.